Hi everyone, today we're going to learn how to name acids. We have been doing nomenclature for all sorts of different compounds so far, but they've not been acids, and there's a whole separate nomenclature system for acids. So the first question you might have is, how do you know that something is an acid? So the way that we know that something is an acid is that it's going to most likely have a hydrogen as the first element in the compound. Now, it could be one hydrogen, two hydrogens, three hydrogens, whatever. But there are some notable exceptions. You may be thinking to yourself, well, wait a minute, water, H2O, starts with hydrogen. That's not an acid. So you're absolutely right. There are exceptions. Another exception you may be familiar with is hydrogen peroxide, H2O2. But for the most part, if you see a hydrogen at the beginning, that kind of tips you off that it is an acid. And we're not going to be trying to trick you or anything like that. So we wouldn't throw something at you that started with a hydrogen that wasn't an acid, with, of course, the exception of water and hydrogen peroxide. So when it comes to naming acids, there are two big categories. There are binary acids, and the next one we're going to talk about, which is ternary acids. Binary, the prefix bi, when you look at that prefix, that should say to you what what does bi mean? Well, it means two, right? So binary acids contain two elements. It doesn't mean that they only have two atoms. It just means it's two different elements. So of course the first element has to be what? That's right, it has to be hydrogen if it's going to be an acid. And then there's going to be another element bonded to it if it's binary. And the prefix for a binary acid is always going to be hydro. So remember, prefixes come at the beginning of the name. And then you're going to name the second element that's in your compound, and then you're going to add the suffix ic acid. So you have to kind of chop the ending off and replace that with ic acid. So let's look at an example. This one may be one that you're familiar with. HCl. That one is called hydrochloric acid. Now look at it. It's got one hydrogen atom at the beginning, so that tells you, okay, we've got an acid here. And then it's got only one other element bonded to it, and that would be chlorine. And so that's two elements in the compound. And so that would be a binary acid. So we start with hydro, and then we put chlor for the chlorine, and then ic acid. All right, so that's how we name that one. Another example, which I like this example because it looks like it's just saying hi, is hydroiodic acid, which is also kind of fun to say. So again, it's a binary acid, two elements in that compound, or in that acid, and so we would start with hydro. The iode part, or the iode part, I guess I should say, is from the iodine, and then we put the ic acid ending on the end of it. So binary acids are pretty easy to name, I would say. The second class or category of acids for naming are ternary acids, and ternary acids are, I've got to be honest, a little more complicated. You're going to want to get out your list of polyatomic ions so you're familiar with those, because ternary acids generally have a polyatomic ion in them. So remember, they're on the back of your periodic table. So I will say, I'm going to go through this list, and it's going to seem a little bit weird at first. Don't freak out, just write it down, and then we're going to go through an example, and then you'll, I think, understand it better. So if you have an acid that is made up of more than two elements, and so that usually means there's a polyatomic ion in there, then that is going to be a ternary acid. So obviously it has to have hydrogen, because otherwise it's not an acid. But then it's going to have at least two other elements in there, maybe three. All right, and usually one of those is going to be oxygen, because as you know, most of those polyatomic ions have oxygen. So if the polyatomic ion that is in your acid, if its name ends in ate, so you can think of some examples like sulfate, nitrate, phosphate, then all you're going to do is replace the ending for that polyatomic ion with ic acid. Now, I will say sometimes it gets a little tricky. You know how sometimes those endings, when you like when we first started learning, like the ides at the end, some, you know, like with oxygen, you chop a lot of it off and just say oxide. With sulfur, you know, you don't chop as much off, and sulfide or whatever. Well, the same thing goes in this situation. And so you kind of got to play with it a little bit and get more comfortable with saying the actual or writing the actual name. So again, we'll practice a little bit. If it's the polyatomic ion in your compound that ends in ite, I-T-E, like nitrite or sulfite, then you're going to replace it with us acid, O-U-S acid. I will say that the list you have of polyatomic ions is not comprehensive, so it's not every single polyatomic ion out there. And so one thing that's good to know is that, remember, polyatomic ions that end in ate always have one more oxygen than the comparative polyatomic ion that ends in ite. Kind of like nitrate is NO3 minus, nitrite is NO2 minus. So that's a good thing to keep in mind as well. Now, this is where it starts to get really wacky. If the polyatomic ion has one less oxygen than the ITE polyatomic ion, you're going to add the prefix hypo and keep the ending us acid. Now, think about the prefix hypo. Maybe back from biology, you knew hypotonic. So that would be less concentrated than whatever it's next to. You might have heard, of course, the word hypothesis, hypothesis. It's not like a solid thesis. It's, you know, a thesis in development, so it's a little bit less. So the prefix hypo usually means less, and so in this case, it's meaning one less oxygen. All right. And then if the polyatomic ion has one more oxygen than the ATE polyatomic ion, now remember ATE is the one that has more oxygens, then, so if we have even one more than that, we're going to use the prefix per, and I'm guessing that that got shortened from the prefix hyper at one point. Remember, hyper means more, so per means one more oxygen, and then we're going to use the ic acid suffix. So again, it's like the ate polyatomic ion, but one more oxygen, and thus we put per and then ic acid. Now, I'm guessing right now you're feeling like, oh my gosh, this makes no sense. I'm super confused. Don't panic. We're going to go through an example, and I think it'll make more sense. And then, of course, practicing will help. All right, so here's an example. So let's start. Let's start with this acid, H3PO4. Now, H3PO4 has a polyatomic ion in it. What is that polyatomic ion? That's right, it's phosphate. All right, so phosphate is the polyatomic ion that, or is a polyatomic ion that ends in ATE. So we change phosphate to phosphoric acid. Now, here's one of those cases I tell you that I would say it's a little tricky because there's no 4 in phosphate, but phosphoric acid I think is hard to say, and it just never caught on. So phosphoric acid. And again, we'll be a little flexible with you as you learn how to do this. Okay, so again, phosphate, ATE, we change the ending to ic acid. Notice there's no prefixes or anything because this is ternary. We don't start adding prefixes until we're either one more or one less than the ate and the ite polyatomic ions. The other thing I want you to notice before we move on to the other example, or the next example, is that phosphate, PO4, has a 3- charge. That's why there's 3 hydrogens bonded to it, because hydrogen's in group 1 on the periodic table, +1 charge when it's in compounds. And so it's going to, the phosphate, so that the total charge adds up to 0, is going to need to be 3 hydrogen atoms bonded to it. All right, now, what do you think would happen if we took away 1 oxygen? So 1 less oxygen than phosphate, That actually would be a polyatomic ion called phosphite, which you haven't learned. It's not on your list. But we know if it has one less, then it's going to have an ITE ending. Well, if it has the polyatomic ion that ends in ITE in the compound, then the ending is going to be us acid. So phosphorus acid has one less oxygen than phosphate. PO3 has one less than PO4. And again, you don't have this, but phosphite has a charge of 3- as well. And so you would need 3 hydrogens to go with that. All right, now, what if we had one less oxygen than that? So instead of H3PO3, we had H3PO2. Now go back to your notes and look and see, what do you do if it's one less? Well, you're going to add the prefix hypo. So H3PO2 is hypophosphorus acid. So we added that prefix hypo. Remember, we said hypo means less than. Another example that came to my mind was hypothermia, right? Hypothermia, your temperature is lower than what it's supposed to normally be. So it's one less than the 3 in H3PO4. And then, of course, lastly, if we had one more oxygen than H3PO4, so phosphate is PO4 3-. If we had one more, that would be H3PO5, yep. And so we would call that perphosphoric acid. So I want you to notice something. I want you to notice that, let me try a different color here now. I want you to notice that the ic acid is used in 2 cases, and then us acid is used in 2 cases. And then per is going to be more than the ic acid, and hypo is going to be one less than the us acid. It's a little wacky. All right, so let's do some examples together. All right, let's try. So this first one is hydrofluoric acid. So pause the video and see if you can figure out what its formula would be. All right, so hydrofluoric acid would be a binary acid. I know that because it has the prefix hydro. And so since it's a binary acid, it's only going to be 2 elements in the compound. The first element has to be hydrogen. Sorry, I'm doing this with a mouse, so it's not going to be great handwriting. And then fluoric acid, okay, that makes you think, what element must that be? Oh yeah, that'd be fluorine, right? Well, hydrogen has a +1 charge in compounds, fluorine has a 1- charge in compounds, so you would just need one of each. So hydrofluoric acid would be HF. All right, let's try this one. Nitric acid. Okay, I want you to notice there's no prefix at all, no hydro. So that tells me, wait a second, that is not a binary acid. It's actually one of the ternary acids. So since it's a ternary acid, it must have a polyatomic ion in it. Now look on your list of polyatomic ions. Do you have a polyatomic ion that would have nitra in it somewhere? Yeah, that's right, nitrate, right? Okay, now this is nitric acid, so that must mean it's the polyatomic ion that ends with what? That's right, ATE. So it would be nitrate in this case. So you got to think about nitrate. Nitrate is NO3 with a 1- charge, so you can only bond 1 hydrogen to that, so the charges cancel out. So you would end up with HNO3. Alrighty, let's try another one. Sulfurous acid. All right, so no hydro, so again we know it is ternary, not binary, right? Right? And it's ending in us acid. So what polyatomic ion would have sulfur in it? That's right. We've got sulfate and sulfite, right? And so would it be sulfate or sulfite if it ends in us acid? Well, us would be the polyatomic ion that ends in ITE, and so it would be sulfite. Now, sulfite is SO3, but what is its charge? That's right, it's 2 minus. So if it's 2 minus, how many hydrogens would we need to bond to it to get a total charge of 0? That's right, it would need to be 2 hydrogens this time. So it'd be H2 SO3, because again, it was sulfite. And we know it's an ite polyatomic ion because it ends in us acid. All right, a few more. Here we go. HBr. Now we're going the opposite direction. Is this binary or ternary? Yeah, it's binary. It's got only 2 elements, hydrogen and bromine. All right, so if it's binary, that should be pretty easy. You just slap on the beginning of the compound the prefix hydro. All right, this is going to be really hard for me to do with this mouse. So hydro. And then it's the element bromine, so it'd be bromic, sorry. If only I had a fancy computer that had a stylus like y'all have. Hydrobromic acid, that's going to be the name. All right. All right, and I believe this is our last one. H2CO3. So H2CO3, binary or ternary? Right, this time it's going to be ternary. So ternary acids have polyatomic ions in them. All right, now CO3, find that on your list of polyatomic ions. What the heck is that? That's right, that's carbonate. Carbonate. So since it ends in an ATE, then that means we're going to change the ending to just ic acid. So this would be carbonic acid. And carbonic acid is actually the acid that we find in soft drinks a lot because it forms when carbon dioxide is dissolved in water and it reacts forming carbonic acid. Oh, I lied. We have one more. So carbonic acid is for H2CO3. The last one, HC2H3O2, is that going to be binary or ternary? That's right, that's ternary because you got a polyatomic ion in there. And this one, the polyatomic ion is C2H3O2. So that is the polyatomic ion acetate. Acetate, again, ends in ATE. So that would be acetic acid. So again, I changed the ending to ic acid. And acetic acid, if you didn't know, is the acid that we find in vinegar. So when you do your baking soda and vinegar reaction to make a tiny volcano, that's acetic acid that is reacting with it. All right, I'm going to stop there.